Hello guys, today our video is about construction of three-phase induction motor and its application. So please watch the video carefully and don't skip the video for full knowledge. Now let's start our video lectures. Today our topic is about three-phase induction motor, construction, operations and types of three-phase induction motor. What is induction motor? The answer is the motor is used to convert an electrical form of energy into mechanical form. According to the type of supply, motors are classified as AC motors and DC motors. DC motors. In today's video, we will discuss the different types of three-phase induction motor with working and applications. The induction motor, especially three-phase induction motor, are widely used AC motor to produce mechanical power in industrial applications. Almost 80% of of the motor is a three-phase induction motor among all motors used in industries. Therefore, the induction motor is the most important motor among all other types of motor. Here is the question, what is three-phase induction motor? A three-phase induction motor is a type of AC induction motor which operate on three-phase supply as compared to the single-phase induction motor, where single-phase supply is needed to operate it. The three-phase supply current produces an electromagnetic field in the stator windings, which lead the torque in the rotor winding of three-phase induction motor having magnetic field. As there we show construction of three-phase induction motor. Here have a look. This is a terminal box and this is our rotor bars, and this is eye bolt from where motor can lift up or placing is used for placing. Here is the rotor and this is the stator winding. This is a stator means stationary winding which cannot move. And here is a non-drive shield. This is a non-drive shield. This red color is a non-drive shield. And this is a motor cooling fan. This fan when the motor is in running form, when the motor heat up, this fan gives the air to cool the motor. And here is a drive and shield. This is a and this is our drive and shield. Okay, this is a shaft key. This shaft key is on the shaft of a induction motor to hold the pulley, and on pulley there is a belt to move mechanical parts. Okay, this is our construction, and this is a fan cover. This is a fan cover, and this is rotor end rings. This is base, and this is the base motor feet from where it can hold by nut bolts, so it cannot vibrate or move. And this is enclosures through which air can pass and cool the motor. and this is mounting holes, and this is a stator, and this is the place of bearing through which motor can move smoothly, and this is motor shaft. This is the shaft of the motor. Okay, this is the construction of induction motor. Now let's see the construction of an induction motor is very simple and robust. It has mainly two parts. There are two parts. One is stator and the other is rotor. These are two types in the induction motor. One is stator. Main parts are stator and rotor. As the name suggests, the stator is a stationary part of the motor. The stator of the induction motor consists of three parts. Here are three parts: stator frame, stator core, and stator winding, as we discussed above. What is stator frame? The stator frame is the outer part of the motor. The function of the stator frame is to provide support to the stator core and stator winding. It provides mechanical strength to the inner parts of the motor. The frame has fins on the outer surface for heat dissipation and cooling of the motor, as we discussed above. The frame is casted for small machine and is fabricated for a large machine. According to the application, the frame is made up of die cast or fabricated steel, aluminium alloys, or stainless steel. Okay. Now here the term stator core. What is stator core? The function of the stator core is to carry the alternating magnetic flux, which produces hysteresis and eddy current loss. To minimize these losses, the core is laminated by high-grade steel stamping thickness of 0.3 to 0.6 mm. These stampings are insulated from each other by varnish. All stampings stamp together in the shape of the stator core and fixed it with the stator frame. An inner layer of the stator core has a number of slots. Now, what is stator winding? The stator winding is placed inside the stator slots available inside the stator core. Three-phase winding is placed as a stator winding, and three-phase supply is given to the stator winding. The number of poles of a motor depends on the internal connection of the stator winding, and it will decide the speed of the motor. If the number of poles is greater, the speed will less. If the number of poles is lesser, then the speed will high. The poles are always in pairs, therefore the total numbers of poles always an even number. The relation between below equation. Ns is equal to 120 F slash P, where as you see here, F supply frequency, P total number of poles, Ns synchronous speed. Okay, as the end of winding to the terminal box, hence there are 6 terminals, 2 of each phase in the terminal box. According to the application and types of starting of motor, the stator winding is connected in star or delta and is done by the connection of the terminal in the terminal box. Here, as you see, this figure, one is a stator and the other is a rotor. As we discussed, stator is the stationary part of the induction motor and rotor is the rotating part of the induction motor. As now let's study the rotor. As the name suggests, the rotor is rotating part of the motor. According to the type of motor, the induction motor is classified as squirrel cage induction motor, phase wound induction motor, slip ring induction motor. Here is the construction of squirrel cage induction motor and wound router. As this is a as you see, this is a uh, copper bars, and this is a laminated core, and this is a metal ring. And here in wound rotor, this is a laminated core, and these are the coils. So types of three-phase induction motors. Three-phase motors are classified mainly in two categories. One is squirrel cage induction motor, and the other is slip ring or wound router induction motor. What is squirrel cage induction motor? The shape of the router is resembling the shape of the cage of a squirrel. Therefore, this motor is known as a squirrel cage induction motor. The construction of this types of router is very simple and rugged. So, almost 80% of the induction motor are squirrel cage induction motor. And slip ring or wound rotor induction motors. Slip ring induction motor are also known as wound rotor. The rotor consists of laminated cylindrical core with slots on the outer periphery. The rotor winding placed in the slots. As electrical diagram of single slip ring three-phase induction motor with external resistance is shown as here. This is stator, and slip ring induction motor stator, and external resistance rotor brush. Here is the brush, and slip ring, here is the router. So see the next are the working principle of three-phase induction motor. The stator winding is overlapped at 120-degree electrically to each other. When a three-phase supply is given to the stator winding, the rotating magnetic field RMF induced in the stator circuit. The speed of the rotating magnetic field is known as synchronous speed ns. According to the Faraday laws, EMF induced in the conductor due to rate of change of flux d pi by dt. The rotor circuit cut the stator magnetic field, and an EMF induced the rotor bar or rotor winding. The rotor circuit is a closed path, so due to this EMF, current will flow through the rotor circuit. So why the slip is never zero in an induction motor? When the actual speed of the rotor is equal to the synchronous speed, the slip is zero. For the induction motor, the condition will never happen, because when the slip is zero, both speeds are equal and there is no relative motion. Therefore, EMF induced in the rotor circuit and rotor current is zero. Hence, the motor cannot run. The induction motor is a widely used motor in industries because it has more advantages and disadvantages. Here is the advantages of induction motor are listed as below. The construction of a motor is very simple and robust. The working of an induction motor is very simple. It can operate in any environmental condition, cold or hot. It never mind. The efficiency of motor is very high. The maintenance of an induction is less compared to the other motors and very easy. It is a single excited motor, hence it needs only one supply of source. It does not require external DC supply for excitation like a synchronous motor. The induction motor is a self-starting motor, so it does not require any extra auxiliaries for the starting purpose for normal operation. The cost of this motor is very less compared to the motors. The life of span of this motor is very high. Armature reaction is less. So what is the disadvantages? The disadvantages of motor are listed as below. During the light load condition, the power factor is very less and it draws more current. So the copper loss is more, which reduces the efficiency during light load condition. The starting torque of this motor, squirrel cage induction motor, is not less. The induction motor is a constant speed motor for the application where variable speed required. The motor is not used. Speed control of this motor is difficult. The induction motor has high starting in rush current. This causes a re- reduction in voltage at the time of starting. Application of three-phase induction motors. So here are the application. The induction motor is mostly used in industrial applications. So application especially where the speed control of motor is needed, such as pumps and submersibles. Submersibles, as you in your home, submersible are for using drawn water. Okay, this is a press machine, lathing machine, grinding machine, conveyor, floor mills, compressors, and other low mechanical power applications. The slip ring motor are used in heavy load application where the high initial torque is needed, such as steel mill, lift, crane machine, hoist, line shaft, and other heavy mechanical workshop etc. So here our topic is, and please subscribe our channel for next lecture and video. Thank you.